Here we are going to find volume of square pyramids. We only do square pyramids in this class, but I'll give you the formula for finding the volume of any pyramid. So volume is 1/3 times capital B times H. H stands for height, the actual height of the pyramid. And the capital B, because it's capital B means area of the base. So depending on what the base is, you would have to find the area of that base, multiply it by the height of the pyramid, and then divide it by 3. And there's your volume. Now for us, we will be doing square pyramids. So area of a square, we have gone over before, is side squared. So let's get into this first pyramid right here. Find the volume of the pyramid. So I'm going to write volume equals 1/3. Now my area of the base, which is 10 squared, because it's a square, side squared, the side length is 10. And then I'm going to multiply it by the height of 12. So we have 1/3 times 100 times 12. One-third times 1200. Now you could, in your calculator, plug in 1/3 times 1200 or 1200, or you could just take 1200, divide it by 3, gives you the same answer, which would be 400 cubic inches. So that would be the volume of this pyramid. So here is my volume formula of this pyramid right here. (11 squared is 121, and then times 12. And again, you can take 1452 and multiply it by 1/3, or take that number and divide it by 3. So the volume of this pyramid is 484 centimeters cubed. Now for this pyramid, kind of a flat pyramid, but they give us the slant height. We are not given the actual height. So I would draw my actual height. And if you notice, if you connect it to where the slant height begins on the side length of the pyramid, you will see that we have a right triangle. We have done slant heights, finding the actual height, back in the Pythagorean theorem chapter. So yes, we are going to have to bring the Pythagorean theorem back. And remember, C is always our hypotenuse, where in this case, our hypotenuse is going to be our slant height. And now our actual height of the pyramid, I will substitute in for A. And then the other leg, we can find the measurement. So the height comes down to the middle of the pyramid, and from the middle to the edge is exactly half of the side length. So half of 48 is 24. So now we can start to solve by using our Pythagorean theorem. So I squared the numbers that I have. Again, I take 48, divide it by 2, and that equals 24, and that is the length of that side. Very important to know that we take the entire side length of the pyramid, cut it in half to help us find the actual height of the pyramid. So this will help us put it into the Pythagorean theorem. So then we can begin to solve. So I have h squared equals 49. Take the square root. The height of the pyramid is 7. So now that I have the height, I can find the volume. 1/3 times area of the base, which is 48 squared, times the height, which is 7. So if 1/3 times 2,304 times 7. And then I get 1/3 times 161,000, or 16,128. Take that number, divide it by 3, and my volume equals 5,376 centimeters cubed. You can get some very big numbers with volume. So last one, again, we are given the slant height, so we need to make a triangle, a right triangle, to find the actual height, h. And the other leg length is half the side length. Well, the side length is 24. 24 divided by 2 is 12, which gives us the other leg length of the right triangle. So if I were to redraw this right triangle, this would be h, this would be 12, and the slant height would be 13. So I use my Pythagorean theorem, where the slant height is always my hypotenuse. And here I get a height of 5 millimeters. Now I can find the volume, 1/3, area of the base. Remember, we have a square pyramid. Pyramids are labeled by their shape of the base, and we are only doing square pyramids because the shape of all the bases are going to be squares. Now let's begin to solve. So I did the area of the square there. I squared 24. And the volume of this pyramid is 960 millimeters cubed.